Welcome back to my channel, everyone, and welcome back to this series of going through exponents and radicals. This is part 2 of the series, and in this video we are going to be going through perfect squares, perfect cubes, and some word problems as well to really deepen your understanding. So let's just get into it. Okay, so starting off with perfect squares, it's good to be familiar with a few, but let me just quickly explain what a perfect square is. It's basically like if you have a factor that when multiplied by itself gives you a number, that number would be a perfect square. Let's do 1 for example. 1 times 1 is 1, so 1 is a perfect square. Okay, and 4 as well, because 2 times 2 is 4, so 4 is also a perfect square. Same with 9, because 3 times 3 is 9, so that 9 is also a perfect square. So since 9's factors are 3 and 3, 9 is a perfect square. So these two are the same number / same factor, and when they're multiplied together, they give you a perfect square. If we're talking about perfect cubes, it's essentially the same thing as a perfect square, except it's multiplied by itself 3 times. Examples of this is, again, 1, because 1 times 1 times 1 gives you 1, so 1 is a perfect cube. And 8 as well, because 2 times 2 times 2 is 8, so 8 is a perfect cube. Or same thing with 3 times 3 times 3 gives you 27, so 27 is also a perfect cube. Same with 64, 125, 1000. Those are all perfect cubes because their factors, their prime factors, when they're multiplied by themselves 3 times, they give you that number. So that makes it a perfect cube. Okay, so those are just the simple definitions, right? But now let's say you don't know if a number is a perfect square or a perfect cube. Let's say you didn't know if 4 was a perfect square. For some reason you just didn't know that. So then again, you break it down using factor trees, and you're like, okay, 2 and 2, and that's really as far as I can go, right? And you're like, okay, well, there's 2 of these, so that means 4 is a perfect cube. Okay, let's try with the number 8 for a perfect cube. Let's say you didn't know that, right? You break it down and you're like, okay, 4 times 2. I've reached this. I can break down 4 even further, so you're like, okay, I break that down into 2 and 2, and guess what? There's 3 2's. They're all the same number, and there's 3 of them, and that gives you 8, so 8 is a perfect cube. So that's how you can break it down if you're unsure. So let's say you're not sure if 36 is a perfect square or not. So you're like, okay, let me break it down using factor trees. So let's say instead of 6 and 6, we decide to go with 18 and 2, because 18 times 2 is 36. You've reached 2, you're like, okay, I can't break that down. 18 can break it down further. Say we choose 9 and 2. Again, we reach 2, and then we break this down 3 and 3. You're like, okay, I have all my prime factors, and I'm at 3 times 3 times 2 times 2. And you're like, okay, well, 3 times 3 does not equal 2 times 2, but you can put them into 2 identical groups, because you can put 3 and 2 together, and then you put the other 3 and the other 2 together. And you're like, okay, well, 3 times 2 is 6, 3 times 2 is 6, and they do equal each other, which means 36 is a perfect square because you could put it in 2 identical groups. Okay, now let's talk about fractions. Fractions can also be perfect squares or perfect cubes, the same way that just regular whole numbers can be perfect squares and perfect cubes. The thing is, both the numerator and denominator would have to be a perfect square or a perfect cube. So if we're talking about perfect squares, an example could be 25 over 36, because 25 is a perfect square, because 5 times 5, and 36 is also a perfect square because 6 times 6, so that works. Could also have 1 over 4, because 1 is a perfect square because 1 times 1, and 4 is also a perfect square because 2 times 2. I feel like that's pretty straightforward for the most part. And then same thing with perfect cubes, could have 8 over 27, for example, because 8 is a perfect cube because 2 times 2 times 2. Same with 27 with 3 times 3 times 3. Another example, just to make sure you get the idea, 64 over 125, right? Because 4 times 4 times 4, and 5 times 5 times 5. Fractions can also be perfect squares and perfect cubes. I have a question for you. Do you think negative numbers can be perfect squares? Just pause the video to come up with a guess and an explanation, and I will go over the answer now. Perfect squares, it is not possible. The reason for that is because you would have to have two of the same, completely identical numbers as factors, and that is not possible with a negative. Because if you're thinking, negative 25 should be a perfect square, but it can't, because this would have to be 5 times negative 5. And now they're no longer identical because one is positive 5 and the other is negative 5. Same with any of them, like negative 9. One of them would have to be positive and one of them would have to be negative. So they're not the same. So negative numbers cannot be perfect squares. But negative numbers can be perfect cubes. And that is because, let's say you have negative 8. Negative 8 is a perfect cube because if you have negative 2 times negative 2 times negative 2, that gives you negative 8, because negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8, and these are all the same numbers. So it is very much possible for negative numbers to be perfect cubes, but it is not possible for negative numbers to be perfect squares. Now, do you think decimals can be perfect squares or perfect cubes? And yes, of course they can. If fractions can be and if whole numbers can be, then why wouldn't decimals be able to be? The thing is though, for perfect squares, decimal places must be in groups of 2. So for example, 0.09, groups of 2, right? This is a perfect square because 0.3 times 0.3 gives you 0.09, and these are identical, so it's a perfect square. A similar thing for perfect cubes, decimal places must be in groups of 3. So if we have 0.064, that works because 0.4 times 0.4 times 0.4 gives you 0.064. Okay, so our first word problem, we're going to go through two. This first one says a square has an area of 169 centimeters square. Determine the perimeter. I'm hoping you understand what the formulas are to find the area and the perimeter of a square. So, as you know, to find the area of a square, it's literally just side times side. And you might be able to recognize, well, these are the same, which means area has to be a perfect square. And so we see the area in this example is 169 centimeters squared. So we can just very simply square root 169 to find what S is. And when we do that, we get 13. So this tells us that each side is 13 centimeters. Now, to find the perimeter of a square, we know that it's 4 times s. So we just simply substitute in the values, 4 times 13, and that gives us 52 centimeters. And that is the perimeter. So it's very important that you're able to recognize perfect squares and perfect cubes, and that you're able to connect it to different formulas, because that's literally how all word problems work. Now let's move on to our next example. This one says the volume of a sphere is given by v equals 4 over 3 pi r cubed. A sphere has a volume of 288 pi centimeters cubed. Determine the radius of the sphere. Now this, you just equate both of them, because it tells you the formula and it tells you what the answer, what the result of that formula is. So since we know the volume formula is given by 4 over 3 pi r cubed, and we know that that is equal to 288 pi centimeters. We don't put the cubed here because that's just the units for the volume, because it's three-dimensional. Then we can cancel out the pi's, just make it a bit simpler. Then we're left with 4 over 3 r cubed is equal to 288 centimeters, which we don't even really need to write that. I don't know why I did. So let's just remove that. And then just perform basic algebra. You have 4r cubed is equal to 288 times 3, which is equal to 864. Divide both sides by 4. Get r cubed is equal to 216. And then if you do know your cube roots, which are the factors that give you perfect cubes, by the way, then this will be really easy. You can, if you haven't memorized, but if not, just cube root it, both sides, and then you know that r is equal to 6 centimeters. Alright, so that basically concludes our video on perfect squares and perfect cubes in relation to exponents and radicals. Stay tuned. There should be about 1 or 2 more parts to the exponents and radicals series. And yeah, I hope you guys found this video educational, and I will see you guys next time.